And we're back with Chapter 6, Microbial Growth. So bacteria divide very simply. They do something called binary fission. And remember that they are able to grow and divide and get large very quickly. And then what will happen is once they have doubled in size, they will make a copy of their circular DNA, and then they will start to divide down the middle until you have two new cells. And they are clones of each other, and that's the reason for their immortality. And this goes on about every 20 minutes. As long as they have food and nutrients, they're all set. So this is showing you what is called exponential growth. And in exponential growth, what's happening is that given enough food, given every 20 minutes or so, they're going to divide in half and make a copy of themselves. They end up exponentially getting large very, 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 very quickly. Rather than get into all the math, this is just proving to you that in 20 generations you can end up with 1 million bacteria where there was one original one. And 20 generations for humans is a lot, but 20 generations for bacteria that does this every 20 minutes, then overnight. So you could have one cell after it divides, it's two cells. The two cells can synchronously divide into four cells. The 4 to 8, the 8 to 16, the 16 to 32, the 32 to 64. I'm not going to test you on this. I just want you to know that it's exponential growth. It's not linear growth. Linear growth would be 1 and 1 is 2, 2 and 1 is 3, 3 and 1 is 4, rather than 1, 2, 4, 8, 16, 32, 64, 128. So that is exponential growth. And that's one of the reason why you can kind of feel off and then go to bed and wake up with a bacterial infection, and you're like, I was fine the day before. But if it gets foothold and you provide it with a lot of nutrients and it does exponential growth, you can be sick the next morning. All right, so this is called the growth curve. So I want you to look at the very as you're looking at the graph on the left-hand side, the lag phase. Now this is like taking a flask and you have media in the flask and you add bacteria. And the lag phase means that they're not growing, they're kind of getting used to their environment. And then all of a sudden they can do tremendous growth. So it says log, L-O-G, or exponential growth phase. Because there's so many nutrients in this flask, they are able to grow exponentially, do that 1, 2, 4, 8, 16, 32, etc. But what will happen if you look at the top of the graph, it plateaus. And that's called the stationary phase. That's when you're starting to run out of nutrients. That flask only has so many nutrients, and it's now going to be the number of bacteria dividing equals the number of bacteria that are dying. And then there's no two ways about it. You're going to start to run out of food, and it's going to end up being a desperate situation until there's no food at all. So as the numbers go down to zero, that's called the death phase. And it is also logarithmic. The idea that the bacteria are going to die the same way that they grow is going to be the basis of how much antibiotics, the concentration, how long you give it to the person, because you definitely want to give them enough of that antibiotic to get the population in the person's body in the death phase. Okay, so this is an explanation of the growth curve, and this is showing you the lag phase, the bacteria that were inoculated into the flask that are adjusting, the log phase, where the bacteria are dividing at their max, the stationary phase, they're running out of food, so the bacteria, the number dividing equal the number dying, and then, of course, they are running out of food and eventually will run out of food in the death phase. So the number that are dying exceeds the number that are dividing. And that's it. So I will see you for the last of this series in a bit. Thank you.